All right, folks. Tonight we're going to be covering some of the Module 1 materials. This is our first night of class here, so this is like the first, delving into the actual content of the course. So I'm going into the study materials here for Module 1. Now, we already did this process, by the way, of um, installing and finding the software, and that's recorded into a separate video. So at this point, the assumption is going into this that you guys have a working software environment to do your code. By the way, if you are stuck and need help getting the environment to work correctly, please, email me and connect with me so I can help you. Maybe a good way to do it is to come to class a few minutes early and handle it there, or stay a few minutes after class and handle it after class. So that's where that first link takes us. The second link here brings up the PowerPoint for the evening, and this is the PowerPoint. If you want to download it, what I do always recommend to my students is, this is provided for a reason. You can follow along with it as I go through the materials. The other thing, if you know this about PowerPoint, is it has kind of a little notes section that's sometimes hidden down here, so you can follow along and type notes into your slides if you wish, that type of thing. Or you can just watch me present it and watch the videos where the PowerPoints are, but they're put together in a very specific way to cover the content materials for the module. And usually there's quite a few slides, and you see how many slides we have. There's over 100 slides in this, and we need to get through this. Yeah, right. Yeah, that seems like a lot, right? Yeah, it sure is. But we need to get through this before the end of Thursday. And it might not feel like we'll get there, but I assure you we will. We'll see how far we can get on this PowerPoint tonight, but that's not where I'm starting. I'm going to start with this other stuff. But if you want to download that, you can do it. You can also view it in your browser if you just click the link. All right. So some of the stuff that we're also going to look at are these outside resources. So I will hit upon all these resources, but here's what I recommend, like as you're starting out this course, what the way you proceed is, if we're providing resources here, we're providing them for a reason, right? Because we think the content is good and it's strong. And so, for example, I'm just going to go here right over to this Microsoft site, and they have a number of different tutorials. And I use this over at the other school where I teach too, pretty heavily. Microsoft has done a lot of work in recent years to put together a bunch of tutorials to teach people how to do stuff. And here's a one, for example, right? The Hello World one, where it tells you how to do it. Now, what's kind of neat, I don't know if you guys are picking up on this, but this is an on-screen tutorial. So they give you, basically the code. You can go into these little windows and copy the code, and you can drop it right into their editor. At least I think you can drop. Oh, there you go. And then you can hit the run button, and you can operate this right inside the browser. How slick is that? Right, pretty cool, by the way. Right. So Microsoft has a number of these. So what I ask is, when we're going into a new unit, so like next Tuesday, when we're going into module 2, that you have already explored all this stuff and tried it out, right? That's kind of my expectation in this class. So there's an example of some of the Microsoft tutorials. And then we also have this website called W3 Schools. And before I click on those links, I'm going to just go to their main website here. And W3 Schools is a really interesting website because the W3 stands for World Wide Web, by the way. So this is a website put together by what we call the World Wide Web Consortium, which is the standards body that makes up all the rules for all the languages and technologies that operate on the internet, by the way. And so if you want to learn especially about HTML, CSS, and JavaScript, this is the site to go to, because they set all the standards for all three of those languages. You will notice across the top bar here, and this is why I zoomed out, that they also have other stuff that you're bound to learn in your program, like SQL, Python, Java, PHP, C#, et cetera, et cetera, et cetera, et cetera, et cetera, right? And all of these sections have extensive examples, reference materials, little on-screen coding engines where you can try the code out. And this, to me, is the singular most important coding reference site on the internet and is worthy of bookmarking in its own right and just knowing that it's there. One thing I always tell my students is when you learn how to code, it feels really overwhelming because you're learning so many different things so quickly, so many terms, acronyms, concepts, and whatever. And then you're like, what did he just say? And if you're like a normal human being, it's easy to forget stuff, especially if you're not doing it all the time. Here's kind of the secret sauce of coders. Coders often don't sit there and memorize things. They learn the basic concepts, but then when they're stuck on something, it's like, oh yeah, how do you do blankety blank in C sharp, right? So I'd come to W3 schools, I go to the C sharp page, and how do I do operators in C sharp? Oh, here it is. Okay, all the info is right there. Great, and you have that reference. So it's not really necessary in this modern age to absolutely internalize and memorize all of this stuff. Have the peace of mind in knowing that there's sites like this on the internet that we can go to that hold the information. So if you forget it, you can go and look it up. So this is an excellent site to do so. C sharp, if you want to I know that like the stuff that we point you to kind of starts here at the comment section, but if you want to read through all the sections here at the beginning of the C sharp tutorial, I would encourage you to do so, very much so. As it says here, this is a language that was developed by Microsoft. It runs on what we call the .NET framework. That's the backend programming libraries that kind of actually creates the working versions of the apps after you write the code. And C sharp is the language that Microsoft uses to build Windows. Pretty much all of its other software packages, you can build websites, applications, mobile apps, games, regular Windows things, whatever. You can build it all with C sharp. It's a very, very powerful language. All right, so this is kind of like the lay of the land relative to this. I am going to kind of come back to this stuff, but I really want to start here, which is this little section here on problem solving. So I'm going to click through on this link, and we actually have a separate page on this, which is kind of interesting because really, in essence, whenever we're writing computer code, we're doing it to solve a problem, right? And this is kind of a weird thought, right? Especially if you're new to programming, if you never really kind of were formally taught this. It's like, well, I never thought of writing an app as solving a problem, but that's usually what apps are for. So it's like, hey, I'd like to make an app that allows me to blank. All right, so you got a scenario. And then the question becomes, well, how do I do that? And so then you're solving the problem of how to do that. And there are techniques that you follow. All right. And you'll read through the material here, and I'm going to zoom in just ever so slightly so it's a little bit easier to see. And it says, when solving a problem, you want to consider what you're trying to accomplish and or what you're trying to solve. Okay, yeah, makes sense. And what I tell my students is the very first step in writing a computer application is understanding what problem you're trying to solve. If you don't understand what you're trying to do, you're not going to be able to do it, period. You think about it. This is true in just about any aspect of life. So for example, when I think about, for example, if I want to build a house, right? How do I start building a house? Right? You don't like get in the car, drive over to Menards, buy a bunch of lumber, some hammer and some nails, and then take it home and get busy. Right? I mean, maybe that would work, like if you knew what you're doing, but chances are you probably have to maybe you want to buy the lot first and make sure you got septic and sewer and electricity, and then maybe pour a slab or dig a foundation. And actually, even more importantly, maybe you need a blueprint. Maybe you need a plan for how to build the house before you go out and buy the materials to build it. Doesn't that make sense? Right? And so problem solving really becomes a process in the coding world where coders often will sit down and plan out what they're going to code before they code it. And there's a lot of different ways to do it. Now we look at problems, and I'll use like the house building comparison a lot. Like if I'm going to build a house, well, what kind of problems do I need to solve? Well, I just pointed out some of them, right? Well, okay, it helps to have a piece of land to build the house on. So somehow you have to solve that problem. I gotta like have enough money to buy the land to put the house on, right? And that's a thing. When you start thinking about all the things it takes to actually build a house, it's a series of a lot of little tiny steps all put together that finally makes it a house, right? That's what this thing is about, right? And you'll have to consider what you have at your disposal to accomplish this goal, then break down that process into steps. This design can be organized using an IPO diagram. And this is a thing that we call kind of like the systems approach, basically, which is this concept that a system, whether it's a computer system or a software system, all utilize this basic structure of input, process, and output, right? And this is kind of weird, right? So notice this next statement. It says, when creating an IPO diagram, start with listing the output, then the input, and lastly, the process. So in other words, if I want to build the house, I'm envisioning what that finished process of that, what that house will look like. Can you imagine? I'll have my own garage and my man cave and my high-speed internet, and it'll be blue and whatever. You have this like vision of what your house looks like. Then you go back and you go, well, what stuff do I need to put into it? Like, what are my inputs to build a house? Well, I need land, I need lumber, probably need concrete and hammer nails and all that stuff, right? And then I have the inputs, but I have to use those in a process or a procedure to actually make it happen. This concept, interestingly, correlates really well to recipes, right? And when I teach my intro programming students over at Gateway, I have them as one of their first assignments in a programming class, give me your favorite recipe. And they're like, what the hell are you talking about? Right? Or like I'm crazy or something. But when I came here to WCTC and saw that, this material, which was probably put together by Brittany, and she's got the exact same thing. And it's like, okay, yeah, I'm on to something, right? Because a recipe is a perfect example. If I want to build a peanut butter and jelly sandwich, because this is what's in my imagination, I'm hungry, I want a PBJ, right? I know what that looks like. All right, but you know what? I got inputs. What are the inputs? Bread, peanut butter, jelly. Well, I also need a plate or a knife or a spoon or something to spread it with, right? And then there's a procedure. And okay, well, what's the procedure? The procedure has to make sense. I take 2 slices of bread, put it onto the plate, right? Then I put the peanut butter on, and then the jelly. And then are you putting peanut butter on one side and then the jelly on the other? Or are you putting the peanut butter on and then putting the jelly on top? You feel where I'm going with this? And then, hey, what kind of peanut butter are you using? Do you really want to use almond butter instead? Or how about this? Is it jam or is it jelly? Heck, I think it was it George W. Bush who always like would have peanut butter and honey sandwiches as his regular afternoon snack? I wonder what the procedure was for that. You know what I mean? But what the inputs are important, but also the minute steps in the process section is mostly what coding is about. You have to think about what your inputs are in a software program. The inputs will be information. This is kind of interesting. It's not going to be physical, tangible objects. It's going to be data you're getting from your user or data that's being provided by a different application or a source on the internet. Then when we get that information, we process it in a certain way. And not to scare you guys, but often in computer programming, the processing involves either math or logic, right? Or a combination of the two to do the process. And the more particularly you can think about the steps in a process, that's what it takes to be a programmer. Thinking about all the little minute steps that users don't even think about, right? They just want it to work. They don't care how it works. They don't care how the peanut butter sandwich is made. They only care if it was delicious. But they will let you know if the ingredients are bad, or if you put too much peanut butter on it and not enough jelly, or vice versa, right? But the process is important. So thinking about it. So a recipe is a wonderful example of this. Here's probably a more typical programming type of example. How about converting a Fahrenheit temperature to Celsius? There's a mathematical formula for this. So what's our input for this, right? Well, the input would be, what is the temperature in Fahrenheit? Then there's a formula, right? And the formula is predefined. And here's a beautiful thing, right? So a lot of students are like, oh, there's math. I'm terrible at math. Oh my God, I don't remember my formula for converting Fahrenheit to Celsius, right? Well, here's the good news. You don't have to remember, right? So even professional programmers aren't figuring out this equation. They usually are working with a scientist or an actuary or, somebody, an engineer that is giving them the formulas. Or if you're using a formula that is as common as this one, heck, you just pop up on Google and say, convert Fahrenheit to Celsius. It'll still pop up right on the screen, right? Or like, what's the volume of a cylinder? Just Google it, right? They'll give you the formula. Your task is to take that formula and convert it into computer code so it operates, right? Ultimately, you're inputting a Fahrenheit temperature. It goes through a process, which is math, and your output is Celsius, right? So that's another example. Here's another one. All right, so let's tie it into gaming, right? Because let's face it, most of us are in IT or programming because we started out with computer games. I am not excluded from that process. Even back in the day, I was a gamer, and it really kind of propelled me. It really made me interested in it, want to learn more. All right, so here's one, right, where we're calling it Mario Run iOS, right? So the input is, all right, so what are we trying to do? We're trying to either have a short jump forward or a long jump forward. The user taps on the screen for the input, and then the process is it a short screen press or is it a long screen press? Short jumps short, long jumps long, right? And so we can take physical interactions on a device that can be our input, right? And the user is therefore controlling which process operates by virtue of how they're interfacing with the device. And we can write code to react to that interface, right? And so the input becomes the user interaction. The process becomes determining what that interaction was and what the user intends. And then the output is having Mario behave in a way that makes sense, right? So there's even a little picture of Mario. Now, this is great when you start thinking about input, process, and output, right? Because a lot of our programs will fit into this scenario. But we also have this thing where when we're doing something and we're thinking about writing code, so I'm going back to the Menards 2x4 hammer and nails example. I don't just run down to the store and buy those things and start building a house. A blueprint is helpful. So how do programmers create blueprints? They use something called pseudocode, which isn't code, it's like code. So it might break down all the steps verbally in plain English to describe what all the silly steps are in the process of getting to that scenario, right? When we figure out pseudocode or the step-by-step process it takes to solve a problem, that becomes a thing we call an algorithm. So if you ever hear this fancy word, algorithm means a step-by-step process for solving a problem. And not only is it step-by-step, but once you've defined the correct way to solve a problem, it should always work. It's not like, well, it's Tuesday, it doesn't work on Tuesdays. It's going to work on Tuesday, Monday, Wednesday, or whatever, if the algorithm is correct. So for example, if we want to write a program that takes two numbers from a user, adds them together, then outputs a sum, the algorithm for that program might be something like, ask the user for the first number, store the first number, Ask the user for the second number, store the second number, add the first number to the second number, and store the sum. That sounds like two steps to me, right? So this could be a separate step. And then output the sum to the screen. So this is the algorithm for doing so. This is not computer code, but it is exactly the steps we would write in the computer code to make it happen. So you might start writing pseudocode that it has really plain English, like the numbered list above, or you could write stuff that sort of looks a little bit more like computer code. So here's an example for the Mario game. Wait for the user to touch the screen, right? So the user touches the screen, they trigger an event, the screen press. If the screen press input is less than a second, then we'll do a short jump animation. If the screen press is greater than a second, then we'll do a long jump animation. And then we just keep looping that. We do it over and over again, right? So this is, once again, is not code. It's starting to look a little bit more like code though. But if you have this logic already spelled out when you go in to write your code, then you're ready to roll with it, right? Because the problem's already solved. You just have to convert it into code. So this is often what programmers start with, right? They start with a breakdown of what the problem is, how to solve it, and then they convert it into code. If you go right into your coding engine and start writing code, especially for something complex, it is more apt that you will fail a lot than if you plan in advance with pseudocode. Aren't you more apt to build a better house if you have a blueprint, right? The blueprint is the algorithm for the house, right? It's the way to solve the problem. Another way, like if a verbal approach isn't good for you, you can use flowcharts. And programmers do this also. And there actually is a formalized language in flowcharting for doing computer programs. And these are some of the standard ones, right? So for example, we always show the start and the end of a program. Those sit in ovals. When we're sending stuff to or from the screen, we usually use a parallelogram. So a square with, or a rectangle with the sides tilted. When we're processing something in the background, we use a rectangle. And then we might also reach decision points. Like, for example, is there more to do? Yes, go back and do it. Is there more to do? No. Then, okay, hey, we did something, right? But the concept is, if you use a visual and you can see it, it is actually very, very helpful. You can see kind of the flow. It's like, first I buy my 2x4s, then I buy my hammer, then I buy my nails, and then I get busy and I got a house, right? But not quite so easy. But, if I have the blueprint, it does go a little bit better. There's more examples of this here, and basically it's just kind of reiterating kind of the whole concept of it. But if I were to take that example from above where we were adding numbers together, here's kind of what it would look like. I'd start the program, parallelogram, ask the user for a number. User types in a number, presses enter. That number gets stored in a variable called num1, so it'll be in storage location in memory. Then we ask the user for another number. They press enter. We take that number and we store it in memory. So we got two numbers stored. Now in the background, I can run a process that takes the first number and the second number, adds them together, stores them somewhere else. Then I take whatever's in that storage location for the sum and I put it back up on the screen. Right. So I have input, right? Input, storing the input, storing the input, the process. And really, these are processes too. So getting an input, processing it, getting an input, processing it, processing the math, and then outputting to the screen. But the grand approach is still input, process, output. Right. It's kind of an interesting little thing. And when you start to think about this in terms of, you can apply this concept to a lot of different things. Like if we were running a manufacturing plant, for example, a manufacturing plant would take raw materials. So let's say I have a paper company. My raw material would be logs from the forest. They would get brought in on trucks. That's my input. Take those logs and I feed them into all these machines. They get processed, they chopped up, mulched up, turned into a pulp, flattened, bleached, put on a big roll. The process turns it into paper. So the input's logs, the process is mulching and flattening and all that, and the output is paper. Interesting. And then you think about your computer systems. We have input mechanisms like a camera, a microphone, a keyboard, a mouse, right? A scanner, right? The computer on the inside has a central processing unit, processes the information, and then we get output on the screen or to a printer or out on the internet, right? Input, process, output is a repeating thing. The other thing I'm going to do here, just really super quick, is I'm going to transport us over to my other school environment here just for a really quick moment. You can see me like logging in here. But I do this thing when I teach my Java class, and we get into working on our final project. I give the students a scenario, and this is actually from when I actually taught in person, if you can believe that or not. And we were in a classroom environment, and we have this very complicated application they have to build for their final project. And what I do is I help them sketch it out. And if you look, this is very messy writing, but I show them why pseudocoding and flowcharting is really important, right? The application that they're building is basically a political survey app. So they're like asking questions, getting opinions, storing the results, and then showing the results of the survey. And so how would that operate? So what we did is we would pre-create all the default survey questions. We would display the menu on the screen. We get the user input, right? So like take the survey, for example, and then we check, is the input valid? If the input is valid, then we branch to one of the choices that they made. Or if it's not valid, we put the menu back up on the screen, right? Makes sense. Then anytime they make a particular menu choice based on the number, we would take that menu choice and break it down here and say, for example, if you're taking the survey, let's display the questions and answers. We get the input from the user. Once again, we check for valid input, right? Then we tally the responses, and then we go back to the main menu. But just by having a roadmap, well, now I know how to code it, right? And really what happens is when you can spell things out like this, you have a guide, you have a blueprint, and now you can build a program. Now, when you do like the homework for this class, where the homework is really much more simplistic than this, you won't really need to blueprint it. You'll just kind of do it, right? But when you build a really complicated app, and this one's not super complicated, but it's complicated enough, if you're not doing this, you will struggle and fail significantly, right? So this is why we pseudocode. This is why we flowchart. This is why we think about what we're doing before we do it. This is why recipes exist for meals, and when you walk into your Thanksgiving meal and all that beautiful food is sitting on the table, think about the fact that each one of those dishes had an input, process, and output that had a plan that's probably written down on a card or a recipe book somewhere to make it taste so delicious. Grandma's potatoes are always delicious, right? So I'm just kind of giving you that correlation, folks. All right, so that's kind of my silly little example of that. All right, what I'd like to do next is I do want to talk about the materials that we have here from these outside resources. So these first two, the Microsoft tutorials, I am going to suggest that you try these on your own, right? A process of self-discovery. They're pretty fun and they're pretty informative. But let's go ahead and take a look at some of this stuff from W3 Schools. And I'm going to zoom in a little bit, and I'm kind of trying to zoom in to the point where I can get rid of most of the ads, by the way. All right, so one thing that we're going to learn about is we're going to be creating a lot of really simplistic little programs as we start out. And in the one case, for example, like the console write line, this is a command we're going to use a lot. Every time we want to put stuff out to the screen, this is our output command, basically. However, this is a piece of executing code. This is non-executing information, right? And we call this a comment. And we often will drop comments into our code to kind of highlight what we're doing, right? So for example, a programmer will often leave notes to themselves inside their code to say, hey, this thing does this and that, right? Because if you look at the code, sometimes you can't tell what it does. And so we call this non-executing code or a comment. So for example, in the W3 schools environment, they have these little try it now tools. And what they do is they give you a complete program. And then, like, for example, this will say hello world. But if I wanted, like, say like hello Milwaukee, for example, right, I can just change the code there, hit the run button, and it will execute in the other environment, kind of like the Microsoft site, right? So you guys can try out some of these features. The other thing that you guys will notice is that when we created a program to try it inside of Visual Studio, pretty much all we saw on the screen was this part. In reality, a true C# program also includes these other components, but in the setup that we're using, these are obscured from us on purpose. We're choosing that because otherwise we go through this like long explanation of like what this stuff all is and where it is. So we will kind of flip back and forth between the two as we move forward. Basically because most of the stuff we're doing simplistically right now fits inside this space. But if you have a correlation, and I'm just saying this for those that already have programming experience, because I get those people, that if you know like Java programming, for example, it's not too dissimilar. If you know Python programming, it's highly dissimilar. It's not at all like Python programming. But this is a traditional C style language. And basically in the C style language, all the stuff that we put on the screen usually sits in blocks of code identified by curly brackets. We have statements that we make that are terminated by semicolons. And these are requirements, folks, in the program to get them to operate. Right. So that's kind of like the brief little view of these. I would ask you to read through all of these. And then, looking at the time here, we're not going to be able to cover much more here tonight. So I'm going to kind of cap it right here. This is our introductory thing. Next week, or not next week, but later in the week, we will dig completely into that module 1 materials and code through the lab assignments. That's going to be our goal. All right. So we're going to cap class here. This video will end right